right? So it's a practice of both, right? Both the squeeze theorem and the continuity. Okay. So we have fx. Right? Already in the question, we are given that fx is greater or equal to 3x, and it's smaller or equal to x cubed plus 2. Okay, only when x is between 0 and 2. Okay, when x is greater than 2 or x is negative, we don't know if this still holds. Okay, but as long as x is between 0 and 2, this is correct. Okay, so first question, what is f1? Okay, so now x is 1, so you can just sub 1 in. Right, so now 3 times x, which is 3 times 1, is smaller or equal to f1. Is smaller or equal to 1 cubed plus 2. Okay, so the left-hand side is 3, smaller or equal to f1, smaller or equal to 3. Okay, so f1 is both greater or equal to and smaller or equal to 3. Then f1 can only be 3. Okay, then f1, the only choice is 3. Okay, so this is the first part. What is f1? Then use the squeeze theorem to evaluate limit fx when x is approaching 1. So to apply the squeeze theorem, we need to check 2 boxes. All right, first box, we need to find a function that's always larger and a function that is always smaller. Right, and this question is very easy because we already know the function. Right, it's always greater or equal to 3x and smaller or equal to x cubed plus 2 when x is between 0 and 2. Okay. And here, let's check our limit. Our limit is when x is approaching 1. Right? 1 is between 0 and 2. So yes, we can use these inequalities. Okay, that's the first box. Right? That's the first condition fx must satisfy to apply the squeeze theorem. The second condition is that both the limit of the left function, right? The limit of the left function, it's very easy. Limit of 3x is just 3. And the limit of the right function, x cubed plus 2, its limit is also very easy. Just do the substitution. It's also 3. Okay? So the limit of the left is equal to the limit of the right. And so both conditions are satisfied, right? Both conditions are satisfied. Then we can make the conclusion that by squeeze theorem, okay, by squeeze theorem, the limit of the function in between is also 3. Okay, it's also 3. Okay. Part C is fx continuous at x is equal to 1. So is f continuous at x is equal to 1? Right, f is continuous at x is equal to 1 if and only if, right, the limit of the function is equal to f1. Right? Fx is continuous at a point A if and only if the function's value at that point is equal to the limit at that point, right? And then from part A, we already know, right? From part A, we already know this is 3. Right? From part B, we already know this is also 3. Okay, so they are the same. Okay, so that's why fx is continuous at 3. Okay, at 1.